I want to quickly do a couple of story problems out of section 5.3. This is where we begin to look at natural exponential functions. This first one, which I've already started, is from section 5.3, problem number 19. And I'm not going to read the problem, you can read it, but this is a problem about crop growth, where this W of t is the amount of crop growth, and they actually weigh it in milligrams to see how much the crop has grown. And now over here you have this W naught, that's how we pronounce this, we have a little zero here, W naught, e to the kt, and W naught and k are just constants or numbers that they give you. And in the problem, they tell us that W naught is 68 milligrams, and the K is 0.2. And now they say, and they tell us also the time here has to be in days. So they say after 30 days, what will our crop growth be? Basically, we have everything we need to plug in here, and then we just do the math. So the crop growth after 30 days is equal to 68 milligrams times e to the kt, which is 0.2, and the t is 30 days. So once again, you have to grab your calculator, where you have the ability to calculate natural exponential functions. So I take 0.2 times 30, that equals 6, and I take e to the 6th, and you get a number, and you multiply that times 68, and you end up with 27,433 milligrams of growth. And that is the correct answer. Let's do a second problem. Once again, these are just not very difficult because they basically give you the equation and you simply have to do the calculating. Number 25 is a blue whale problem. Let me read it quickly. In 1980, the population of blue whales in the southern hemisphere was thought to number 4,500. The population NFT has been decreasing according to a formula, which they give you in the book, where t is in years and t equals 0 corresponds to 1980. If this trend continues, predict the population in the year 2015. So they're trying to calculate the number of whales that are left, and they have this equation they're going to use. N sub t, where n is the number of whales, and they said it equals 4,500. Now this is a nasty looking number, negative 0.1345 times t. And it's important for t to be in years. And what's also very important is 1980 is when t equals 0. So 1980 is like the starting point. So 1980 represents year 0. So therefore, they're asking us to find the number for 2015. Well, if 1980 is year 0, what year would 2015 be? Well, it's been 35 years past 1980, so now I'm going to plug in my equation, t equals 35. So now it's just a matter of doing some math. So really, I'm calculating n of 35, so 4,500 e to the negative 0.1345 times 35. And now, once again, hopefully you're all becoming experts on using your calculators. So 0.1345 1, 3, 4, 5, a negative, times 35 equals, and that's going to be the exponent on my e, and I multiply that times 4,500, and if they say in the problem, normally you round it to the nearest whale, it's 40.6, normally you round down. So basically you say there are going to be 40 whales left. Alright, so once again, these problems are just not very difficult because they give you the equation and your job is to simply plug in the numbers to grab your calculator and to be able to do the calculation on your calculator. So hopefully you will not find these too difficult.